Picture this. There are somewhere between 100 and 400 billion stars in our Milky Way galaxy alone. Many of these stars have planets. Some of those planets sit in the Goldilocks zone, not too hot, not too cold, just right for liquid water and potentially life. Now multiply that by the estimated 200 billion galaxies in the observable universe. With those mind-boggling numbers, the universe should be absolutely teeming with intelligent civilizations. Some of them should be millions of years more advanced than us, capable of technologies we can barely imagine. So here's the disturbing question. Where is everybody? Why haven't we detected a single alien transmission? Why hasn't anyone visited? Why don't we see massive engineering projects around distant stars? The silence is deafening, and it's been puzzling scientists for over 70 years. This mystery has a name, the Fermi Paradox, and the possible answers range from hopeful to absolutely terrifying. Some suggest we're just not looking hard enough. Others hint that intelligent civilizations inevitably destroy themselves. Stick around as we explore why the universe might be a lonelier place than we ever imagined. And don't forget to subscribe. The lunchtime question that changed everything. The story begins in 1950 at Los Alamos National Laboratory, where some of the world's brightest minds were working on atomic energy projects. During a casual lunch conversation about UFOs and interstellar travel, physicist Enrico Fermi suddenly asked his colleagues, "Where is everybody?" It seemed like a simple question, but Fermi had done the math in his head. The Milky Way is over 10 billion years old. Even with modest technology and slow spacecraft traveling at just a fraction of light speed, any civilization could colonize the entire galaxy within a few tens of millions of years, a blink of an eye in cosmic terms. Our galaxy should have been colonized countless times over by now. Yet when we look around, we see nothing. No alien megastructures, no interstellar empire, no evidence of anyone out there at all. This contradiction between the high statistical probability of alien civilizations and the complete absence of evidence became known as the Fermi Paradox. It's not just about why aliens haven't visited Earth. It's about why we don't see any signs of them anywhere in the entire observable universe. The Drake equation, doing the math. In 1961, astronomer Frank Drake tried to quantify the question by creating what's now called the Drake equation. It multiplies together factors like the rate of star formation, the fraction of stars with planets, the number of habitable planets per star, the fraction that develop life, the fraction that develop intelligence, the fraction that develop detectable technology, and how long such civilizations last. When Drake and his colleagues first worked through the equation, their educated guesses suggested there could be anywhere from 1,000 to 100 million communicating civilizations in our galaxy alone. Even conservative estimates often produce thousands of potential alien societies. So why the silence? The problem is that most of the equation's variables are complete guesswork. We've made progress on some factors. We now know that planets are extremely common, with billions of potentially habitable worlds in our galaxy. But the later factors remain total mysteries. What's the chance that life develops? That it becomes intelligent? That it develops technology? That it survives long enough to be detected? A 2018 study suggested that when you use probability distributions instead of single values, there's a substantial probability, perhaps 53% to 99.6%, that we could be alone in our galaxy. The math suddenly looks a lot less optimistic. Possible explanations. The lonely ones. Let's explore the possible solutions, starting with the sobering possibility that we might actually be alone. We're rarer first. Maybe Earth is genuinely special. Perhaps the conditions needed for complex life are far more specific than we think. Recent research suggests that factors like long-lasting plate tectonics and the right balance of oceans and continents might be extraordinarily rare, occurring on only 0.003% to 0.2% of planets. If most planets can't develop complex life, that would explain the silence. Alternatively, maybe we're simply among the first intelligent species to emerge. The universe is 13.8 billion years old, but the earliest stars lack the heavy elements needed for rocky planets. Perhaps we're part of the first generation of civilizations, and we're looking around at a galaxy that's still mostly empty for now. Life is harder than we think. Perhaps the jump from non-life to life is spectacularly difficult. Maybe Earth got incredibly lucky, and most planets stay sterile forever. Or perhaps simple life is common, but the leap from single-celled organisms to complex, intelligent beings is where most planets fail. It took Earth about 4 billion years to go from bacteria to humans. Maybe that's usually where the story ends. The Great Filter, our biggest fear. But here's where things get truly unsettling. What if intelligent life is common, but something stops civilizations from spreading across the galaxy? This idea is called the Great Filter, a concept proposed by economist Robin Hanson in 1996, suggesting there's at least one step in the progression from simple matter to spacefaring civilization that is extraordinarily unlikely. The terrifying question is, where is the filter? If it's behind us, if the filter was the origin of life or the evolution of intelligence, then we're incredibly lucky to exist, and the future looks bright. We've passed the hardest test. The galaxy might truly be ours to explore. But if the filter is ahead of us, then we're approaching a nearly insurmountable barrier that has destroyed countless civilizations before us. Maybe it's nuclear war. Maybe it's climate catastrophe. Maybe it's artificial intelligence run amok. Maybe it's something we haven't even imagined yet. The silence in the universe wouldn't be because intelligent life is rare. It would be because intelligent life keeps destroying itself. Think about that for a moment. Every advanced civilization might reach a critical point where their technology becomes powerful enough to annihilate them. And if none have made it past that point, what are our chances? This is why philosopher Nick Bostrom said that in the context of the Fermi Paradox, the silence of the night sky is golden. Finding even simple life on Mars would be terrible news, because it would mean the filter is likely ahead of us, not behind us. They're out there, but we can't see them. Of course, maybe aliens exist, but we simply haven't detected them yet. Space is incomprehensibly vast. Our nearest star system, Alpha Centauri, is 4 light-years away. Reaching it with current technology would take thousands of years. Interstellar travel and communication might be far harder than science fiction makes it seem. Perhaps civilizations don't actually want to colonize the galaxy. Maybe they build virtual realities and live digital lives instead of spreading physically across space. Some researchers suggest advanced beings might upload themselves into virtual environments, losing interest in the physical universe entirely. There's also the dark forest hypothesis, inspired by science fiction. The idea proposes that the universe is filled with civilizations that stay silent and hide, because revealing yourself to the cosmos is existentially dangerous. Any civilization that broadcasts its presence might attract the attention of more powerful civilizations that see competitors as threats to eliminate. In this scenario, the universe isn't empty. It's full of civilizations staying quiet and hunting in the darkness, like predators in a forest. Or perhaps there's a zoo hypothesis. Aliens know about us but are deliberately avoiding contact, treating Earth like a nature preserve where primitive life can develop naturally without interference. What we're doing about it. Despite the puzzle, scientists haven't given up searching. The Search for Extraterrestrial Intelligence Initiative has been scanning the skies for radio signals since the 1960s. Modern telescopes are finding thousands of exoplanets and can soon analyze their atmospheres for signs of life. We're sending our own messages into space and listening more carefully than ever before. Every year we rule out more possibilities and narrow down where to look. We're finding that Earth-like planets are common. We're discovering that the building blocks of life exist throughout the universe. We're learning that life can survive in far more extreme conditions than we once thought. But we still haven't heard anything. The universe remains stubbornly silent. What it means for humanity. The Fermi Paradox isn't just an abstract scientific puzzle. It has profound implications for our future. If civilizations typically destroy themselves, we need to take that possibility seriously. It means we should be extremely careful with technologies that could threaten our existence. Nuclear weapons, climate change, artificial intelligence, biotechnology, and things we haven't invented yet. On the other hand, if we're truly alone or among the first, that places an enormous responsibility on our shoulders. We might be the universe's only chance to fill the cosmos with consciousness, art, science, and meaning. We could be the ancestors of civilizations that will eventually spread to the stars and light up the galaxy. Arthur C. Clarke famously said, "Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying." And he was right. Being alone means carrying the weight of being life's only success story. Not being alone raises questions about why no one has contacted us and what that silence really means. The bottom line. So where are all the aliens? The honest answer is, we don't know. Maybe they're out there, and we just haven't found them yet. Maybe we're looking in the wrong places or listening for the wrong signals. Maybe life is far rarer than we think, or maybe intelligence is common, but spacefaring civilizations are not. Or maybe, and this is the possibility that should keep us up at night, the universe is littered with the remains of civilizations that reached our level of development and then failed a test we're approaching right now. The Fermi Paradox reminds us that we know embarrassingly little about our place in the cosmos. We're still in the cosmic dark, making educated guesses about one of existence's biggest questions. But that's also what makes it exciting. Somewhere out there might be answers. Or perhaps we're writing the first chapter of a story that will determine whether the universe stays silent forever or eventually fills with voices. The search continues, and maybe in our lifetime, we'll finally hear something back from the darkness. Or maybe the real lesson of the Fermi Paradox is that survival itself is the ultimate achievement, and we should appreciate how special it is to be here asking these questions at all. If you enjoyed exploring this cosmic mystery, hit that subscribe button and let me know in the comments. Do you think we're alone, or are they out there hiding? Thanks for watching.